Okay, we'll first start with the solving of the equations. And after that we'll see how to eliminate the variables or elimination of the variables. So these are the two tasks which we will be going to do in the today's class. So have you done any basics on this in the previous classes?
We did theory.
So we did the basic theory of this.
So we did theory of equations.
Have you done the solving of the equations? And have you done the elimination of these variables? Okay, so today we will solve some of the questions. Maybe we will take how exactly we solve the system of equations and how exactly we eliminate the variables from the given set of equations. So let's take the first question. So if given x into y plus z is 44 and y into z plus x is 50 and z into x plus y is 54. So mostly in solving of the equations, our aim is to find the values of x, y and z. So there are a lot of ways, or you can say a lot of methods which we use in solving of the equations. So one such method is you open up the brackets, you add all the equations. What happens if I open up the brackets and if I add all of them?
2 into xy plus yz
So
plus
we get xy plus xz here, and we get yz plus zx here, and zx plus zy. That will be equal to 50 plus 54 and 44. We're just adding the left hand side part and we're adding the right hand side part. So what do we get? 2xy, 2yz, 2zx, and that will be equal to 148. Now just take 2 common. And you take that to that side. So we get 74. Now if I see the first equation, this equation is nothing but xy plus xz is 44. So in place of xy and xz, I can substitute 44. So what do I get? 44 plus yz will be equal to 74 and yz will be equal to
20.
Similarly, if I apply the same thing on other equations, what do we get? So if I use the second equation now, we have yz plus zx is 50. So yz plus zx, in place of that if I substitute 50, I get xy is equal to 74 minus 50, which is 24. Similarly, from the last equation I get yz and zx in place of yz and zx.
सर सेकंड इक्वेशन में yz और yx होगा ना?
Yes, sorry.
yz plus yx.
Yes.
zx.
And the last equation we get xy will be equal to 74 minus 54, which will be equal to 20. Now we have 3 variables, three values, yz and zx and xy. You multiply all of them. What do I get?
X square, y square, z square.
So we get x square into y square into z square will be equal to 24 into 20 into 30. So this can also be written as 6 square into 2 square into 10 square.
Yes, sir.
24 is 6 4s are 24, and you can write 2 into 3 as 6, and 10 into 10 is 10 square. So basically this is 6 square into 2 square into 10 square. Any doubt in this? So just take the square root on both sides. I get x, y, z will be plus or minus 120. So once we get x, y, z value, I already know the y, z value. Y, z value is 30. So in place of y, z you substitute 30. Then you get x value as plus or minus 4. Similarly, you get y value will be zx is 24. So this will be 5, and xy is 20. So you get z as plus or minus 6. Clear, right? Just use these three equations in this equation x, y, z and find out the value of x, y and z. So this is the first type of solving of the equation. Whenever they give you the normal equations with the linear variables, then what we do is you just open up the equation and see whether is there any pattern you can see in the variables as a combination of 2, 2. And whenever you have all the types of variables in the pattern of 2, 2, what we do is we multiply all of them to get a perfect square. We'll use a similar method in other questions as well. And let's take one more question of a similar kind. So we just started with the first question initially. The first question was x into y plus z is equal to 44, and y into z plus x is 50, and z into x plus y is equal to 54. So we have been given three equations, and whenever we have to solve the equations simultaneously, or if you want to solve these three equations, what we do is, in case of the linear variables, we just multiply them and open up the equations and just add them everything. So once you add all of them, you get the sum of them. These variables are xy plus xz and yz plus zx, and zx plus zy is equal to 50, 54 and 44. And if you just simplify and if you add them, you are getting xy plus yz plus zx as 74. So once you get this value from the previous equation, we already have xy plus yz is 44. If I substitute that, you get the value of yz as 74 minus 44, which is 30. Similarly, if you use the other two equations, you get zx and xy value. Once you have these all the three values, you just multiply all these three equations. So if I multiply all these three equations, we get xy into yz into zx as x square, y square, z square, and the values are 24, 20 and 30. If I multiply them, we are getting the value as 6 square into 2 square into 10 square. If I take the square root, we get 6 into 2 into 10, which is plus or minus same as 120. Now once you have the value of x, y, z, using these equations, yz is equal to, yz we got it as 30. So use the value of yz in this place, find out the value of x. Similarly, use the other two equations to find out the values of y and z as well. Now let's take the one more equation of the similar type. We have x into x plus y plus z is given as a square, and y into x plus y plus z is given as b square, and z into x plus y plus z is given as c square. Now we want to find x, y, z again from these equations. We use the similar method. So we use a similar method. Just open up the brackets and just multiply each and everything. If you open up the brackets, what do you get?
y square plus z square plus 2 into xy plus yz plus zx is equal to a square plus b square plus c square.
So this value is same as
X
X
plus
plus
y
y
plus
plus
z
z is whole square.
Now if I take the square root, so let's assume this value as some k or something.
Excuse me, sir. You have to pass it over.
So we got x plus y plus z as plus or minus square root of a square plus b square plus c square. Let's assume that value as k. and then further simplify. So from the first equation I have x into k is equal to a square, and from this next equation I have y into k is equal to b square, and from the next equation I have z into k is c square. So from here we get x is equal to a square by k, and y is equal to b square by k, and z is equal to c square by k, where k is nothing but plus or minus root of a square plus b square plus c square. Clear, right everyone? So basically what we are doing is, whenever you have these kind of equations, linear equations, just multiply or open up the brackets, add each and everything, so that you get similarity, or you can say a similar form, where you can convert them to a perfect square, or by multiplying, if you are getting a perfect square, this thing, you just use that method, find out the value of x plus y plus z. Once you get this, you substitute back to find out your individual variables. Let's take one more equation. So again we have x into x plus y plus z is given as now a minus yz, and here we have y into x plus y plus z is given as b minus xz, and here we have z into x plus y plus z is given as c minus xy. So we want to find x, y, z values. So in this case also, just open up the brackets and see what we are getting first. If I open up the brackets on the first equation, we have x square, xy, xz will be equal to a minus yz. Bring that yz this side. Now here, instead of adding each and everything, what we have to do is, we will use the factorization. So how can I factorize this? If I take x common in this too, what do I get?
X plus y.
X plus y. In this, if I take z common, I get
X
x
minus
plus
y.
y. So in both the terms I have x plus y, just take x plus y common. So what do I get? X plus y into x plus z will be equal to a. Similarly from the other equations, y plus z into y plus x will be b, and the last equation, z plus x into z plus y will be c. So just similarly you expand this to other two equations and factorize them, you get these variables. Now this is looking like x into y and y into z and z into x is given as some values. Again what we do, you multiply each and everything. So if I multiply all these equations, what do I get? X plus y whole square, y plus z whole square, z plus x whole square will be equal to ABC. Now again take the square root. If I take the square root on both sides, what do I get? X plus y into y plus z into z plus x will be equal to plus or minus root ABC. Again if I assume this is equal to some k, so x plus y into y plus z into z plus x is some k value. Now we already know x plus y into x plus z is given as a. That means x plus y, and in place of x plus z I can substitute a. That will give me y plus z into a will be equal to k, or y plus z will be k by a. Similarly substitute the other values as well. From the second equation, if I substitute, I get y plus, in place of y plus z and y plus x, if I substitute, I get z plus x, that will be equal to k by b, and the last equation will be x plus y will be equal to k by c. So I got now again three set of equations. Add everything. If I add everything, what do I get?
2 into x plus y plus z.
So 2 into x plus y plus z will be equal to k times 1 upon a plus 1 upon b and 1 upon c. Now take that to other side. So we get 1 upon a plus 1 upon b plus 1 upon c into k by 2. But from the first equation, we already have y plus z as k by a. So in place of y plus z, you substitute k by a. And you take k by a onto the other side, what do you get? Anyone who has a doubt?
हाँ कॉल कर लिया सर. ओके थैंक यू सर. हाँ बस.
सर आवाज आ रही है?
अभी ना. हाँ ओके.
जलगांव सेंटर माइक ऑफ कीजिए अपना.
So for those students who just joined, you mean whatever class you have missed, refer the YouTube. Although I have solved 2-3 questions, all the 2-3 questions will be uploaded on the YouTube. So refer YouTube for the questions which you have missed.
जलगांव सेंटर माइक ऑफ कीजिए.
So if I take LCM here, what do you get? So again, if I take k by 2 common, final answer will be 1 by b plus 1 by c minus 1 by a. So what we are trying to do is, first we are trying to get rid of the product of the variables into sum of the variables. Here, as we have in the product of the variables, you just multiply each and everything to get in terms of the linear variables. So the reason for taking this as k is, wherever you get square root of ABC, instead of repeating every time square root of ABC, just assume this as some constant and we will try to represent everywhere that as a constant. Now we got the value of x. Similarly, if I use the second equation, I can find the value of y. We get the value of y as k by 2 will be 1 by c plus 1 by a minus 1 by b. Similarly, you get z value as k by 2 into 1 by a plus 1 by b minus 1 by c. So when I am trying to find the value of x, the coefficient of a or the coefficient of 1 by a is minus. Similarly, when I am trying to find the value of y, coefficient of 1 by b should be minus. Similarly, when you are trying to find the z value, 1 by c value is having the minus sign. So this type is clear, right? So whenever you are having a multiplication of say complicated variables, at the end what your aim is to get each and everything into individual variables where you can add them up and find out the individual values. So at the end maybe you can substitute the value of k again. We got k as plus or minus root of ABC. Wherever you have k, you replace that k with square root of plus or minus square root of ABC. Let's take one more question. So now here we have 4 variables x, y, z as well as v. And each and every equation consists of 3 variables and 1 constant. Here a, b, c, d are constants and x, y, z and v are your variables. So while solving these kind of equations, again you have to find the variables only. Whenever you are solving for the equation, try to find the variables. Now in order to solve these kind of questions, again add each and everything. As we have each and everything is in the form of linear variables, use the same method, add all the equations. What do I get? X plus x 3x, y plus y will be 3y, 3z and 3v will be equal to, now if I take 3 common, and if I take 3 other side, so we already have the value for x plus y plus v. So in place of x plus y plus v, you substitute this value. So we have z plus b is equal to a plus b plus c plus d by 3, and take that b other side, you get so when you take LCM, you get a plus c plus d minus 2b by 3. Because when I take LCM, this will become 3b, b minus 3b will be minus 2b. So once you have the value of z, similarly use the other 3 equations to find out the other variables also. So when I use this equation, we will get the value of y. So y will be equal to a plus b plus d minus 2c by 3. And when I use the third equation, you get the value of x, which will be a plus b plus c minus 2d by 3. Similarly, when I use the last equation, I get the value for v, which will be b plus c plus d minus 2a by 3. So again, if you see the symmetricity in this, when I am using this equation, the variable which is missing from here is z. So that's why for z, the only thing which is getting changed is the value which is on the right hand side. So when I am using the first equation, the 2b is having a minus sign, and when I am using the second equation, c is having the minus sign. Similarly for the other two equations as well. Clear, right? So now let's solve a different set of equations. See, all this while we were solving the equations which does not have any coefficients. Now what if our variables are having a coefficients where a, b, c are constants again, x, y, z are your variables. Now we want to find the values of x, y, z again from these three equations. So in these kind of equations, again our motive is to get rid of the coefficients from x, y again. In order to get rid of these coefficients, what I can do is from the first equation, I can divide by AB on both sides. So if I divide on both sides by AB, what do I get? So we get AY by AB plus BX by AB will be equal to C by AB. So A gets cancelled, here B gets cancelled. So we have Y upon B plus X upon A will be equal to C upon AB. Similarly, divide the second equation by AC. If I divide second equation by AC, so what do we get? We get x upon A, z upon C will be equal to B upon AC. Similarly, if I divide third equation with BC, divide third equation with respect to BC, what do we get? Z upon C, Y upon B will be equal to A upon BC. Now if I see these three simplified equations, here I have Y by B, here also I have Y by B, here I have X by A, here also I have X by A, here I have Z by C, here also I have Z by C. Now add these three equations. If I add these three equations, what do I get? 2 times X by A plus Y by B plus Z by C will be equal to A upon BC plus B upon AC plus C upon AB. Now if I take 2 common and if I send it that side, what do I get? X by A plus Y by B plus Z by C will be equal to half times A upon BC, B upon AC plus C upon AB. So again we got this into the same format of the previous equations. When I have the three equations and if I already have that format x by A plus Y by B, in place of that I can substitute this value C by AB. In place of x by A plus Y by B, I can substitute the value as C by AB. So when I substitute that, what do I get? C by AB plus Z by C will be equal to half times A upon BC plus B upon AC plus C upon AB. Now take this C by AB that side we get Z by C will be equal to half times
A by B.
so now instead of this plus C by AB, that will become minus C by AB. Now if I just take that C other side, what do I get? Z will be equal to C by 2 into, to take LCM here, LCM will be APC,
A square plus B square plus C square.
and you can cancel C in the numerator and denominator. So your final answer for Z will be A square plus B square minus C square by 2AB. Similarly, if I repeat the same process using the second equation, I can find the value for Y.
Y.
Y will be coming out to be A square plus C square minus B square by 2AC. Similarly, if I find the value for X, X will be coming out to be B square plus C square minus A square by 2BC. So what we are trying to do here is, when we are having an equation with respect to some coefficients, first divide by that coefficients on the both sides and try to convert them into fractions. So when we convert them into fractions, and if I just add each and everything, provided both of them are of same fractions. Let's say if one of the equation is of x by a, and in another equation if I am having x by b, we cannot do this format. Only when I have x by a and x by a in both the equations, then only we will add all of them and we will try to get that in the format of 2 into x by a plus y by b plus z by c. When I add each and everything, I am getting a linear equation. In that linear equation, I am using the help of other equation using the substitution method and then simplify. So once you simplify, we are getting the value of z. Once you get the value of z, in the similar process, if I use the other two equations, this equation and this equation, you can find the values for y and x. Now let's take one more question of the similar type. So in the previous question, we just had a constant on the right hand side, but in this question, if I have the variables, other two variables as well on the other side, so there is no need of division here. You just directly take this variable as a division onto the other side. If I take the first equation, what do we have? Cy plus bz, if it is equal to 2d yz, you bring this yz this side, we get cy plus bz will be equal to 2d. Then if I again separate them, I get
C by Z plus D by Y is equal to 2.
सर सेकंड और थर्ड में वो apostrophe जैसा क्या है?
So basically we have different values here. The first equation consists of d, other equation is d dash, and the third equation is having the variable as d double dash. All these d's are not same. All these d's are different d's.
So that is a constant.
Okay fine.
All these are constants only but different. Like a, b, c, you can assume they are like d, d dash and d double dash are the different variables. Now if I divide by yz, we have c by z here.
D by Y.
b by y will be equal to 2d. Similarly, if I repeat the same thing on the other two equations, what do I get? A by x and c by z will be equal to 2d dash, and in the third equation, b by y and a by x will be equal to 2d double dash. Again we are getting the same format. Here I have b by y, here also I have b by y, a by x and a by x, and c by z and c by z. Add all of them again. If I add all of them, what do we get? 2 times of a by x, b by y plus c by z will be equal to 2 times d plus d dash plus d double dash. I can cancel 2 on both sides. So basically we have the value a by x plus b by y plus c by z is equal to d plus d dash plus d double dash. Now from the first equation, we have c by z plus b by y is equal to 2d. So in place of c by z plus b by y, I can substitute 2d. So when I substitute 2d in this place, what do I get? A by x plus 2d will be equal to d plus d dash plus d double dash. So a by x will be d dash plus d double dash minus d. or x will be equal to a by d dash plus d double dash minus d. If I repeat the same process using the next equation, I get the value for y. Y will be coming out to be b by d plus d double dash minus d dash. If I repeat the same thing for the third equation, we get the value for z as c by d dash d plus d dash minus d double dash. So what exactly we are doing in this is, basically you just divide by this yz which is there on the right hand side, and again try to get that in the same format of the linear equations type, where you get just add all of them and convert them into simple equations where you can find the individual variables. Clear, right? So let's try one more question of the similar type. So again we have been given three equations but in a different format. So if the three equations are being given, again try to convert them into the standard format. I should have xy in the denominator and this one should be in the numerator. So if I repeat that, if I take the reciprocal of each and every equation, what do I get? Ay plus bx by xy will be equal to 1 by c, and az plus cx by xz will be 1 by b, and bz plus cy by yz is equal to 1 by a. Now this is looking like in the same as the previous question. We just simplified. You don't try this one. Just using the same method, just try to simplify this. So again, if you just divide them, you get these equations. Just add all of them and then try to simplify for x, y, z. So if I add all of them, so using the first equation, if I substitute now, we get the value for C, we get the value for Z. So if I just take this 1 by C that side, you get the answer as 1 by A plus 1 by B minus 1 by C. Now if I take LCM on the other side, LCM will be ABC, and here we have BC, AC minus AB. Now I want to find the value of Z, so take that Z that side, bring everything onto one side. So Z will be equal to 2ABC square by BC plus AC minus AB. Just cross multiply, this 2 is in the denominator, so 2ABC into C will be your numerator now. Z will be going to the numerator and this numerator will be coming to the denominator. So similarly, if I use the second equation, you can find the value for y. So then y will be equal to Similarly, you can find the value using the third equation. You can find the value for x. X will be equal to
2ABC upon AB plus AC minus BC.
So is this method clear, right, everyone? So whenever we have coefficients along with the variables, what we do is first we try to divide by that coefficients and get them in the simple format where we can add all of them to get into a simple equation. Using that simple equation, you can just substitute the other equations values to find out the individual variables. Let's try a different pattern now. So if the given equations are y plus z minus x is equal to xyz by a square, z plus x minus y is equal to xyz by v square, x plus y minus z is equal to xyz by c square. Now here, if I add all of them, it might not be helpful to find out the individual values. In these kind of questions, whenever you have one minus coming in between the equations, first what we do is we add two equations only, or term by term we will be adding a sets. Maybe first you add 1 and 2, after that you add 2 and 3, after that you add 1 and 3. So what happens when I add first and second equation? I get y plus z minus x plus z plus x minus y will be equal to xyz by a square plus xyz by b square. Now here I can cancel minus x and plus x and plus y and minus y. So what do we have here?
2z.
2z is equal to, I can take xyz common, we have 1 by a square plus 1 by b square. Now if I cancel z also, what do we have? 2 is equal to xy into a square plus b square by a square b square. Now just if I keep xy on one side, take everything on the other side, we will get xy will be equal to 2a square b square by a square plus b square. Now similarly, if I add second and third equations, what do I get?
2y.
So if I add second and third equations, y gets cancelled and z also gets cancelled. You get 2x will be equal to xyz out. So you can cancel x, and if I take everything on one side, you get 2b square c square by b square plus c square as yz. So we got xy value, we got yz value. Similarly, use the first and the third equation. If I use first and the third equation, what do I get?
2y.
X gets cancelled, z gets cancelled, y plus y will be 2y will be equal to and I can cancel y also here, and xz value will be equal to then 2a square c square by a square plus c square. Now again this is looking like the first equation or the maybe second equation where we got the value of the first question type, where we got the value of xy, yz and xz value. When we have these three values, what we do? You multiply all the three. So when I multiply all the three, I get x square, y square and z square will be equal to 8 times. When I multiply all the numerators, we have a square b square c square and c square a square. We get
8 times a raised to 4 b raised to 4.
4 and c raised to 4, and in the denominators we have a square plus b square into b square plus c square into c square plus a square. Now if I take the square root on both sides, we get xyz will be equal to plus or minus 2 root 2, and in the denominator you have square root of a square plus b square plus c square and c square plus a square. Now this is the value for xyz, and we already have the value for xy. So in place of xy, if I substitute this value, I can find the value for z. So substitute the value of xy from this equation in this place. We get the value for z. So I can cancel a square b square on both sides. I can cancel 2 also. So we can find the value of z now. Z will be equal to a square plus b square goes to the numerator. We have plus or minus root 2 c square into a square plus b square so this is the value for z. Similarly, if I use the other equation, yz value in this place, I can find the value for x also. So if I substitute the value for yz in this equation, we get the value of x as plus or minus root 2 a square into b square plus c square by root of a square plus b square into b square plus c square into c square plus a square. Similarly, if I use this equation xz value in this place, I get the value for y as plus or minus root 2 times b square into a square plus c square by root of a square plus b square into b square plus c square into c square plus a square. So clear, right? In this type, whenever we have a minus sign coming in the equation, what we do is we add term by term, or you can say equation by equation, or maybe in the next type when we are trying to eliminate x, y, z, there we can also multiply also in order to get rid of these things. So whenever we see the minus sign, don't just add all of them at a time. You might not get the answer using that method. So let's take a different type. So if the given equations are z plus ay plus a square x plus a cube and z plus by plus b square x plus b cube and z plus cy plus c square x plus c cube. If these are the three given equations, so it's a different type. If I add all of them, we might not get the answer in this type. So in these kind of questions, what is the similarity we can observe here? So z, y, x are same, just the coefficients are getting changed. So these kind of things we can relate this to polynomials. So I can take a general polynomial of type p cube xp square and yp plus z is equal to 0. If I have a polynomial in terms of p, where p is the variable for the polynomial, if I have a polynomial of this whose roots are abc, if I take a polynomial whose roots are abc, that will satisfy these complete three equations. In place of p, if I substitute a, I get the first equation a cube plus a square x plus a into I plus z is equal to 0. Similarly, when I take the value of b, I get the second equation. Similarly, when I take the value of c, I get the third equation. Now we know that if I have a polynomial of this type, whose roots are a into a, b, c, I can write the polynomial as basically p minus a into p minus b into p minus c.
Yes.
So we know when the roots are a, b, c, the polynomial can be expressed as p minus a into p minus b into p minus c. Now if I just open up the brackets on the right hand side, what do I get? P square minus ap minus bp plus ab into p minus c. Again multiply everything, we get p cube minus p square c minus ap square minus acp minus bp square plus bcp and ab into p and minus abc. So when I multiply all of them, we are getting this equation. Just open up and just multiply each and everything. We have p cube, p square into p is p cube, p square into c minus c will be minus p square c. Next minus ap into p will be minus ap square, minus ap into minus c will be plus acp, and next multiply minus bp into p minus c. Similarly multiply ab into p minus c. So when I open up all of them and simplify this, what we get? P cube, let's write it here. So on the left hand side we have p cube plus xp square and yp plus z, and on the right hand side we have p cube. If I collect the coefficients of p square or minus p square, what do we have? Minus p square c, minus p square b and minus p square a. So if I collect all the coefficients of minus p square, we get the value as a plus b plus c. Similarly, if I collect the coefficients of P now, we have plus P into
AC plus B.
AB plus BC plus AC, and the last term which is remaining is minus ABC. I am telling that left hand side equation is equal to the right hand side part. Then just equate the coefficients. PQ gets cut, and the coefficient of P square on the left hand side is X, and the coefficient of P square on the right hand side is minus of A plus B plus C, and the coefficient of P on the right hand side is Y, and the coefficient of P on the right hand side is AB plus BC plus AC, and the coefficient of, so we don't, the constant on the left hand side is Z, and the constant on the right hand side is minus ABC. So you can find the values of X, Y, Z using this method only when we have a polynomial. So you can use that also using the sum of the roots, product of the two roots, and product of the three roots also.
Sir, Borivali.
Yeah, tell me.
Sir, is there any other method for this question?
See, I mean, you can use the remainder theorem, or you can say the quotient theorem, which you have done in the polynomials. But there are few students who haven't done this. That's why I'm not discussing that method here. But that is there in your books. If you just refer the RMO book, the method is explained in your book also. We can use the remainder theorem or the quotient theorem, or maybe you can use the sum of the roots, product of the two roots, and product of the three roots as well. But this is the easiest method, I can say. Once you just add and you just use the comparing of the coefficients, that will be easy. So if the given equations are x into sine A plus y into sine 2A plus z into sine 3A is equal to sine 4A. And the next part you have x into sine B plus y into sine 2B plus z into sine 3B is equal to sine 4B. Similarly, the last equation is of x into sine C plus y into sine 2C plus z into sine 3C is sine 4C. So in these kind of questions, you cannot use again this method. If I start using this method, the question gets complicated. Instead, what we use is we can use a little of trigonometry and simplify the given equations first. So we know that sine 2A is 2 sine A cos A, or else maybe for those students who haven't done this, just note down these formulas first. Sine of A plus B is sine A cos B plus cos A sine B, and sine of A minus B is sine A cos B minus cos A sine B, and cos of A plus B is cos of A minus B will be cos A cos B plus sin A sin B. So now let's use these formulas to derive the formulas for sin 2A, sin 3A and sin 4A. So if I use sin A plus B formula for sin 2A, I can write it as sin of A plus A is sin 2A. Now if I use that formula sin A plus B, formula is sin A cos B plus cos A sin B. So this is same as sin A into cos A and sin A into cos A, which is written as 2 sin A cos A. So in order to find next sin 3A, I can write sin 3A as sin A plus 2A. Sin A plus 2A is basically sin 3A. Now if I apply the formula again, I can write this as sin A cos B sin A cos B, this is A, this is B. Sin A cos B plus cos A sin B. Now we have sin A here. Again you have to apply for the formula for cos 2A. Cos 2A can be written as cos of A plus A, which is written as cos A into cos A, which is basically cos square A. You can tell me what's your doubt? I can't hear you properly. What's your doubt?
So can you please go a little slow?
Yeah, okay. So basically what we are trying to do is, we are trying to find the formulas for sin 2A, sin 3A and sin 4A using these formulas. In this, first we find the formula for, let's find the formula for sin 2A and cos 2A first. So we have sin 2A. Sin 2A is written as sin of A plus A. So sin of A plus A is sin A cos B plus cos A sin B. In place of A and B I have the same angles. So just use the same angles. What do we get? Sin A into cos A plus cos A into sin A, which is same as, both the terms are same. You just add them, you get 2 sin A cos A. If I use the same formula for the finding the formula for the cos 2A, we get cos of A plus A is cos 2A, and use the formula of cos A plus B. In place of A and B you substitute A only. We get cos A into cos A minus sin A into sin A. So cos A into cos A is cos square A, sin A into sin A is sin square A. Or else I can also write this as, we know the identity sin square theta plus cos square theta is always equal to 1. Sin square angle, sin square some angle plus cos square of the same angle will always be equal to 1. So in place of cos square I can use 1 minus sin square, or in place of sin square I can use 1 minus cos square. So I can write this as cos square A minus of 1 minus of cos square A. In place of sin square A I am substituting 1 minus cos square A. So basically the formula for cos 2A can also be written as 2 cos square A minus 1, or it can also be written as cos square A minus sin square A. See, what we are trying to do here is, we have cos 2A as cos square A minus sin square A. Here we have an identity which says that sin square theta plus cos square theta will always be equal to 1. That means for a theta, for some value of angle, if I take the values of sin square as well as cos square, the addition of them will always be equal to 1. So in place of sin square, what I am doing is, I can write as 1 minus cos square A. So here we have a sin square A value. In place of that, you substitute 1 minus cos square A. So in place of sin square A, I am substituting the value of 1 minus cos square A. So if I just simplify this, cos square A, if I open up the brackets, I get minus 1 plus cos square A. If I just add them, you get 2 cos square A minus 1. So the value or the formula for cos 2A can also be written as 2 cos square A minus 1. Or we can have one more formula for that. Cos 2A can also be written as, now instead of cos square A, if I write it as 1 minus sin square A. In place of cos square, if I write it as 1 minus sin square A and minus sin square A, we can also write it as 1 minus 2 sin square A. So basically cos 2A has 3 formulas. So cos 2A can be written as cos square A minus sin square A, or it can also be written as 2 cos square A minus 1, or it can also be written as 1 minus 2 sin square A. So depending on the question, we will be using one of this formula. We won't be using all of them at the same time. Now let's find the formula for sin 3A using all these formulae. So sin 3A is sin of A plus 2A. So again use the formula of sin A plus B. Sin A plus B is sin A cos B plus cos A sin B. In place of A I have A, in place of B I have 2A. So wherever you have A, you replace it by A, and wherever you have B, you replace it by 2A. You get the value as sin A cos 2A plus cos A sin 2A. Now we know the formula for cos 2A. Just substitute the formula for cos 2A. We'll write down the question again. We'll write the question again. First, wrote down all these formulas first. So we have sin A.
Simplify, we get 3 sin A minus 4 sin 2A.
Let's simplify step by step. So we have cos 2A as cos square A minus sin square A, and sin 2A is 2 sin A cos A. Now if I just simplify this, we have sin A into cos square A minus sin cube A and 2 sin A cos square A. Now if I want to keep everything in terms of sin, or if I want to keep everything in terms of cos, we can do it whatever way we want. Let's keep everything in terms of sin first. So if I want to keep each and every term in terms of sin, so wherever you see cos, you replace that using this identity. Cos square A can be written as 1 minus sin square A so wherever you have cos square A, replace that with 1 minus sin square A and just simplify. We get sin A minus sin cube A minus sin cube A plus 2 sin A so if I just add all of them, we get
Sir. Sir, I didn't understand.
we are just applying the formula sin A plus B. See, just go through step by step of this. We are just taking sin A plus B and applying the formula of each and everything. And at the end, what we are trying to do is expressing everything in terms of a single trigonometric function. Maybe it can be sin or it can be cos. So sin A plus 2 sin A is coming out to be 3 sin A. Sin cube and 2 sin cube is minus 4 sin cube A. So the formula for sin 3A is 3 sin A minus 4 sin cube A. So just note down these formulas. We will be using this formula in solving this question. All these are formulas, yeah. So once we have the sin 3A, now we need to simplify sin 4A also. So sin 4A can be written as 2 times 2A. So 2 times 2A is nothing but sin 4A. But what is the sin 2A formula? 2 sin A cos A. That means sin 2A can be written as 2 sin 2A cos 2A. Again apply sin 2A formula here. You get 4 sin A cos A into cos 2A. Now simplify again, write the formula of cos 2A here. So we have cos 2A as 2 cos square A minus 1. So you can write this as 4 sin A cos A into 2 cos square A minus 1. So I mean, we won't be using this formula. We will see why exactly we are using everything in terms of cos. So for time being, just remember sin 4A is nothing but 4 sin A cos A into cos 2A. In place of cos 2A, we are using the second formula, which is 2 cos square A minus 1. Now just note down all these formulas and let's simplify sin 3A also in terms of cos. If I take sin common here, we get 3 minus 4 sin square A. So in place of sin square A, I can substitute 1 minus cos square A again. So in place of sin square A, if I substitute 1 minus cos square A, what do we get? 3 minus 4 plus 4 cos square A, so which is same as sin A into 4 cos square A minus 1. So just note on all these formulas, sin 4A and sin 3A, sin 3A and sin 2A. So we'll be using all these formulas in the next question to simplify the question. So let's take the question again. So let's take first equation and then simplify what we are going to get. In place of sin 2A, if I substitute the formula, sin 2A is 2 sin A cos A. And in place of sin 3A, if I substitute this formula, and in place of sin 4A, if I substitute this formula, so what exactly is common in each and every term? In each and every term we have sin A. So just cancel the sin A out and see what we are going to have in the question. If I simplify it further, what we are going to get? X plus 2y cos A plus z into 4 cos square A minus 1 will be equal to 4 cos A into 2 cos square A minus 1. So each and every term is in terms of, or maybe the whole equation is consisting of now cos only. Now if I assume cos A is equal to t, now this will convert into automatically polynomial form. If I take cos A is equal to t now, what do I get?
X plus 2yt
Now this is a polynomial form for which I can apply sum of the roots and product of the roots and sum of the product of two roots. So we have t as cos A, but my equation is based on 3 variables. One is A, other one is B, and other one is C. So this polynomial has 3 roots.
सर
Yeah.
सर वो अपने 2 साइड कैंसिल किया है ना
I cancelled only
Y
sin
के बाजू
A.
में
I have cancelled sin A in each and every term, not 2 sin A. There is no 2 for the first term. We have only x into sin A in the first term. So we just cancelled sin A on the each and every term.
ओके सर
Now with this, we have 3 equations in terms of A, B, C. First equation is in terms of A. Next equation is in terms of x into sin B plus y into sin 2B plus z into sin 3B. Next we have one more equation, x into sin C plus y into sin 3C plus y into sin 2C plus z into sin 3C is equal to sin 4C. So we have 3 equations in terms of A, B, C. So the roots of this cubic equation will be, or you can say the roots of the form cos A, cos B and cos C. Now if I take everything on one side, we have the polynomial as 8t cube minus 4zt square. Take everything on the other side, we had 8t cube minus 4zt square minus 4t minus 2yt plus z minus x will be equal to 0. Take everything on the other side, you get 8t cube minus 4zt square minus 4t minus 2yt plus z minus x is equal to 0. So we have minus 4zt square. If I take minus t common, we have 4 plus 2y plus z minus x. Now for the polynomials, what is the sum of the roots? Cos A plus cos B plus cos C are the roots we have assumed. If t is equal to cos A, cos B, cos C, these three are the roots. And sum of the roots will be minus coefficient of t square by coefficient of t cube.
Minus 4 upon 8.
So 4z upon 8. Similarly, what is the value for product of two roots?
Minus 4 plus 2y by 8.
Plus coefficient of this by coefficient of t cube, which will be minus of 2y plus 4 by 8. Similarly, product of three roots is given by
Z by 8. Minus Z by 8.
minus of constant term by the coefficient of t cube. Now I have the single variables x, y, z, and the left hand side terms are all the constants only. So if I take the first equation, I have z by 2 is equal to cos A plus cos B plus cos C. That means z will be equal to 2 times cos A plus cos B plus cos C. Now if I take the last equation is given by cos A into cos B into cos C is x minus z by 8. Now we know the value of z. Substitute the value of z and find out the value of x. If I cross multiply, I get x minus z is equal to 8 cos A, cos B, cos C. Now x will be equal to z plus 8 cos A, cos B, cos C, where value of z is this 2 times cos A plus cos B plus cos C plus 8 times cos A plus cos B, into cos B into cos C. So this is the value for x. Now similarly, from the second equation I can find the value for y. So y value is given by 2y plus 4 by 8 with a minus sign is given by cos A cos B plus cos B cos C plus cos C cos A. Now take everything on one side and just keep y on this side. So we get minus 2y plus 4 will be equal to 8 times I can cancel 2. Now I want to find y, so take 2 on to the other side. So we get the value of y as minus 2 minus of 4 times cos A cos B plus cos B cos C plus cos C cos A. So your values for x, y, z are, this is the value for z, this is the value for x, this is the value for y. So we are using again the polynomial method only, but before converting this to polynomial method, what we are trying to do is, we are trying to simplify using the trigonometric formula. After that only we are applying the polynomial method. Clear, right? So let's try one more question of this type. Not so complicated, but where okay, let's do maybe a simple question, not of this difficult type maybe. So So let's try one last question of this type. After that we will discuss the elimination of variables.
सर जो आपके बाकी जो इक्वेशंस है उनका यूज नहीं हुआ इसमें ना
Can you repeat the question?
आपने तीन इक्वेशन दिए थे और एक को सॉल्व किया आपने
See, the reason because if you just simplify the other two equations also, you are going to get the equation of the same form but with a different variable. In terms, in place of cos A, you are going to get cos B. In the third equation, in place of cos B, you will get cos C. That's why we have solved one question right previously. We had a question. So in the previous question we had taken a polynomial where z plus ay plus a square x and a cube, and we have one more equation z plus by plus b square x plus b cube. So in place of that, what we did, whenever a variable which is just changing, or you can say the constant term which are the coefficients of that variable that is changing, in place of that we have assumed the new polynomial term which is t, and then we have given three roots to it, which are terms of cos a, cos b and cos c. So using again the polynomial method only we are trying to solve the question. Clear, right? So let's take a simple question maybe instead of a complicated one. See, given three equations, y plus 2x plus z is equal to a into y plus x into z plus x, z plus 2y plus x is equal to b into z plus y into x plus y, x plus 2z plus y is given as c into y plus z into x plus z. Solve for x, y, z. Can you tell me one obvious solution for this?
So we can multiply in the brackets and
No, before multiplication. What is the obvious solution for this?
We can add the
we can add no, we can't.
I am asking for the obvious solution. If I substitute x, y, z as 0,
Acha.
the equations will satisfy.
Yes.
So, in place of x, y, z, if I substitute 0, left hand side will be equal to the right hand side. So, one solution is definitely x is equal to y is equal to z is equal to 0. Apart from this, there might be other solutions also. We will try to find the non-zero solution now.
Okay, answer आ गया
It's not yet done, we still have to do. So, one solution is zeros and there can be one non-zero solution also. Let's try to simplify this now. So if I just add all of them, what do I get? Y plus 2y plus y is
4y.
and 2x plus x plus 2x is, so 2x plus x plus x is 4x,
And
4z on the left hand side, and on the right hand side you have a times y plus x into z plus x plus b times z plus y into x plus y plus c times y plus z into x plus z. So we have 4 times x plus y plus z on the left hand side, and that will be equal to just if I open up the brackets on the numerator, what do I get?
So A into yz plus yx plus xz plus x square into b into plus b into zx plus zy plus yx plus y square plus c into yx plus yz plus zx plus z square.
Or else instead of using this, instead of adding them, what we can do? Instead of adding them, if I treat x plus y plus z as some constant k, each and every equation has x plus y plus z. Let's take some variable instead of k. Let's take some variable only, maybe something like L or something. Wherever you have x plus y plus z, I can write L. That means the first equation will be L plus x, and the next equation will be L plus y, and the third equation is L plus z. So L plus x is given as A times y plus x into z plus x, and this is B times z plus y into x plus y, and the third equation is the first motive is to find the value of L, or maybe before you find L value, we can further simplify this.
So we can write that as L minus Z, y plus x as L minus Z.
Yes.
Can we add these two equations?
Yes. If you add them, what do you get?
3L plus L means 4L equals this. Yeah, L plus L.
ऐड करके कुछ आ जाने सेम हो जाएगा
सर y plus x को L minus z.
So we have L plus x is equal to A times L minus z into L minus y and L plus y is equal to B times
L minus x.
if I multiply all of them,
बहुत अच्छा होगा.
or else instead of this you multiply all of them only. If I multiply all of these three, you get L plus x into L plus y into L plus z is equal to ABC into x plus y whole square, y plus z whole square into z plus x whole square. Now take the square root on both sides. Now using this equation, we have y plus x into z plus x value as L plus x by A. So if I substitute that value here, what do I get? X plus y into z, x plus z, which is y plus z into L plus x by A, and here we have plus or minus root of L plus x into L plus y into L plus z by ABC. Okay, so in the previous question, I did a small error. Instead of taking all the variables x plus y plus z as single constant, what we have to do is, we have to take two variables as single constant. A single variable x plus y, if I take it as L, y plus z as M, and z plus x as N, the equation can be rewritten as, I will get this equation when I add first and third. When I add these two, I get 2x plus y plus z is equal to L plus N. So the first equation is nothing but L plus N is equal to A times L into N. Similarly, next equation will be L plus M will be equal to B times L into M. Similarly, third equation will be M plus N will be equal to C times M into N. Now this is the same as the previous thing which I have already done. If I divide by ln on the left hand side, what do I get?
1 by n plus 1 by n is equal to a.
So if I just separate this, I get 1 by n plus 1 by L is equal to A. Similarly, 1 by M plus 1 by L will be is equal to B, and 1 by N plus 1 by M will be equal to C. Just add all of them. You get 2 times 1 by L plus 1 by M plus 1 by N is equal to A plus B plus C. So if I take 2 on the other side, what do I get? 1 by L plus 1 by M plus 1 by N is equal to half of A plus B plus C. Now we already have the value of 1 by L plus 1 by N, which is A. So in place of 1 by L plus 1 by N, you substitute A. So if I take A onto the other side, you get 1 by N is equal to half of B plus C minus A. Similarly, if I use the other two equations also, you get 1 by M as half of, now if I use the second value, I get 1 by N, which will be equal to half of A plus C minus B. Similarly, 1 by L will be given as half of A plus B minus C. So now we have the value of 1 by M, 1 by N and 1 by L. Now let's simplify this in the reverse format. Like if I take the value of 1 by M also here, 1 by M is half of B plus C minus A. Now if 1 by N is this, N will be given as 2 by A plus C minus B. If 1 by L is this, L will be equal to 2 by A plus B minus C. If 1 by M is this, then M will be 2 by B plus C minus A. But what is L, M, N? X plus Y, Y plus Z and Z plus X. So before you proceed further, let's take the constant for A plus B plus C also. Everywhere we have A, B, C. If I take A plus B plus C as some constant P or something, if A plus B plus C is P, I can write N as 2 by, or instead of P, let's take 2P. Then I can write this as 2P minus 2B, the denominator. If I take A plus B plus C as 2P, then A plus C minus B will be equal to 2P minus 2B. So in place of this, you substitute 2P minus 2B. Similarly, L will be equal to 2 by 2P minus 2C, and M will be equal to 2 by 2P minus 2A. Now add all of them, L, M, N, or let's say take the value of N. N was, what was the value of N? So we have taken L as X plus Y, M as Y plus Z, and n is equal to x plus z. So substitute the values back. Wherever you have n, you use x plus z again. Wherever you have L, use x plus y. Wherever you have M, use y plus z. Now add all of them. What do I get? 2 into x plus y plus z will be equal to, so 2 by 2p minus 2a plus 2 by 2p minus 2b plus 2 by 2p minus 2c. You can cancel 2 everywhere. So we get x plus y plus z as half of 1 by p minus a plus 1 by p minus b plus 1 by p minus c. Now this is looking like the same thing in the first equation what we solved. I have x plus y value and I have x plus y plus z value also. Now substitute the value of x plus y in this. If I substitute the value of x plus y is 1 by p minus c. So substitute these values in place of the given equation. So we get x plus y is equal to 1 by p minus c. So z will be equal to half of 1 by p minus a plus 1 by p minus b plus 1 by p minus c. So take this 1 by p minus c that side. We get z is equal to half times 1 by p minus a plus 1 by p minus b minus of 1 by p minus c. Similarly, if I do the same thing using this equation and this equation, you find the values for y is equal to 1 by p minus a plus 1 by p minus c minus of 1 by p minus b. So x value is given by half of 1 by p minus b plus 1 by p minus c minus 1 by p minus a. So the solution for x, y, z is all these values provided, substitute the values of all the things. P was assumption as a plus b plus c by 2. So wherever you have p, you write it as a plus b plus c by 2. So the solution for given equation will be x, y, z as these values. So the mistake what I was did is, like these kind of questions, whenever you have more than variables combined with the different coefficients, like in the first equation we have a coefficient for x as 2, in the next equation we have a coefficient for y as 2, in the other equation we have a coefficient for y as z as 2. So these kind, instead of taking all the variables as single variable, you take two variables as a single variable and then simplify. Clear, right? So let's take one more question. Maybe one last question of the solving of the equations. After that we will start with the elimination of variables. So now when I have equations like this, y plus z plus yz is a and x plus z plus x into z is b, x plus y plus x into y is c. So here instead of linear variables I have product of the variables as well. So in these kind what we try to do is, we try to factorize the given equations. So in order to factorize this, what we do is, if I take the first equation, we have y plus z plus yz is equal to a. What we do is, you add 1 on both sides. So if I add 1 on both sides, what do we get? So if I add 1 on both sides, I can take z common from these two terms. Then I get 1 plus y plus z into 1 plus y is equal to a, or it is also same as 1 plus y into 1 plus z is equal to a. Similarly, if I add 1 to the other two equations as well,
There should be a plus 1, right?
yes, sorry, a plus 1. So if I simplify the other two as well, 1 plus x into 1 plus z is given as b plus 1, and 1 plus x into 1 plus y will be c. So now these are the three simplified equations. I can multiply all the three. If I multiply all these three equations, what do I get on the left hand side? 1 plus x whole square, 1 plus y whole square, 1 plus z whole square will be a plus 1 into b plus 1 into c plus 1. Now if I take the square root on both sides, I get 1 plus x into 1 plus y into 1 plus z is equal to plus or minus square root of a plus 1 into b plus 1 into c plus 1. Now if I see the first equation, we have the value of 1 plus y into 1 plus z. Now in place of 1 plus y into 1 plus z, I can substitute a plus 1. I get 1 plus x into a plus 1 will be equal to plus or minus square root of a plus 1 into b plus 1 into c plus 1. So in order to find the value of x, you take a plus 1 onto the other side. So if I take a plus 1 onto the other side, you get 1 plus x is equal to plus or minus square root of a plus 1 into b plus 1 into c plus 1 by a plus 1. If I simplify it further, I get 1 plus x is equal to plus or minus square root of b plus 1 into c plus 1 by a plus 1, but inside the square root, because square root of a plus 1 and a plus 1 I can cancel and I can take a plus 1 inside the square root. Now the value of x is given by minus 1 plus or minus square root of b plus 1 into c plus 1 by a plus 1. Now this is the value of x. Similarly, if I use the next equation, I can find the value of y. So if I use the second equation now, that is given as 1 plus x into 1 plus that is b plus 1, that gives me 1 plus y will be equal to plus or minus square root of a plus 1 into c plus 1 by b plus 1. Now if I keep y here and take the minus 1 that side, I get a plus 1 into c plus 1 by b plus 1. Similarly, z will be given by minus 1 plus or minus square root of a plus 1 into b plus 1 by c plus 1. So whenever you have product of two variables along with the linear variables, add a necessary constant. Sometimes it need not be 1, sometimes you might have to add 2, 3, 4 depending on how the factorization is possible. So if the factorization is possible with respect to 4, you are supposed to add 4 only instead of 1. So make sure you factorize them and convert them into product of two things, and again use the same method which we are trying to do in the previous questions. Now let's start with the elimination of variables. See, in elimination of variables, what they give is, they will give you two equations or maybe more than two, and they will ask you to get rid of x, y, z and form a condition in terms of constants only. Like till now what we are trying to do is, they will give us the equations and we are finding the solutions for x, y, z. Now instead of that, what we do in elimination of variables is, they will give you two or more equations and we will try to eliminate x, y, z and we will try to form the condition on a, b, c or whatever values we have in terms of constants. So before we start solving the questions, let's discuss one concept of the intersection of the lines or solving the equations simultaneously. Let's say if I have line equations or maybe a simple linear equations like this, ax plus by plus c is equal to 0 and lx plus my plus n is equal to 0. Let's say if two equations are given like this, and if I want to find x and y, we can use the simultaneous equations method and solve, or else from now onwards directly remember this formula. I can write this as x by bn minus cm, or this is also equal to y by cl minus an, that is equal to am minus bl. So when you solve simultaneously, the values of x and y are going to be, if I equate this value to this, whatever is the value of x you are going to get, that will be this value only, bn minus cm by am minus bl. Similarly, if I want to find the value of y for this equation using simultaneous, just equate these two values, you get y is equal to cl minus an by am minus bl. Or what exactly we are doing here is, in order to find the value of x, you forget these values ax and lx and you take the coefficients of this and just cross multiply. B into n minus C into m. So Bn minus Cm. Similarly for y, what we do is you forget this y values and you take the multiplication of A into n and C into L, but you take a minus sign for that. We get An minus Cl, but for the center value always you multiply that with the minus sign, whereas in order to find the last value you remove the constant and you just cross multiply these variables, these constants, A into m minus B into L. So that's how we get the values of x and y. Or if you are not understanding this, basically what we are trying to do is, if you simplify this simultaneously, this is the solution we are going to get. So remember this formula. This formula is very helpful in solving the questions in the elimination of variables. Instead of solving them simultaneously every time, if you remember this formula, you can solve the questions within 1-2 steps itself. Let's take a question using this method. So let's say if the given equations are ax square minus 2a square x plus 1 and a square plus x square minus 3ax is equal to 0. So they have given us two equations in terms of x. Try to get rid of the variable x and form the condition in terms of a only, a and the numbers, whatever constants you can. So you have to solve them simultaneously and get rid of the variable x, form a condition in terms of a. If I rewrite these two equations in this format, I can write this as ax square minus 2a square x plus 1 is equal to 0, x square minus 3ax plus a square is equal to 0. Now again, if I apply this formula now, elimination of, if I apply the simultaneous equations formula, what I can write? X square by cross multiplication of minus 2a square with a square is minus 2a power 4 minus 3a plus 1 with along with the minus sign will give me plus 3a here, and x with minus a cube plus 1 and 1 with minus 3a square plus 2a square. I am using the same formula. In place of x we have now x square, in place of y we have now x. Take all the coefficients and just substitute here. So in place of b I have minus 2a square, and in place of n I have a square, and in place of c I have 1 now, and in place of m I have minus 3a. So in order to find the value of bn minus cm, that is same as b into n minus c into m. That will give you minus 2a power 4 plus 3a. Similarly, if I apply the same thing for the center variable, you multiply a into a square, that is a cube, and 1 into 1 is 1. But we will take 1 minus a cube in this case, that is the reverse of the variables. And in the last case, you forget this and you just take the multiplication of this. A into minus 3a is minus 3a square, minus 2a square into 1 is minus 2a square, but again with the minus sign, so that will become plus. We are just using this formula in order to write the answer directly. Now if I just equate this with this and this with this step by step, I get x square will be equal to, or x square by 3a minus 2a power 4 will be equal to minus 1 by a square, because minus 3a square plus 2a square is minus 1 by a square only. Then x square value will be equal to minus of 3a minus 2a power 4 by a square. Now similarly, if I equate x with this, I get x by 1 minus a cube will be equal to minus 1 by a square, or x will be equal to minus of 1 minus a cube by a square. Now I have the value of x, I have the value of x square. Now I want to get rid of x. So basically in place of x, you substitute this value. So if I substitute the value of x in place of x square, now the whole equation will be in terms of a only. So in place of x I substitute minus of 1 minus a cube by a square whole square will be equal to 2a power 4 minus 3a by a square. If I just simplify this, whatever equation I am going to get, that will be the condition which we will get by eliminating the variables of x from the given two equations. So if I just simplify this, what I am going to get, this is 1 minus a cube whole square by a power 4 will be equal to 2a power 4 minus 3a by a square. So you can cancel one a square here, and you can take this a square onto the other side, and this is a minus b whole square. A minus b whole square is a square plus b square minus 2ab, and if I take a square on the other side, 2a power 6 minus 3a cube. If I just take everything on one side, a raised to 6, 2a power 6 minus a power 6 is a power 6 minus 3a cube plus 2a cube will be minus a cube plus 1, if it is goes outside it will be minus 1. So the answer, or maybe the condition, in order to, after eliminating the given two equations in terms of x, we will be getting the condition as a power 6 minus a cube minus 1 will be 0. So in the exam, what kind of questions you will be getting is, they will give you like this 2 or more equations, and you need to get a condition in the final step which should not consist of any of the given variables. So clear, right? Elimination of variables. Let's take one more question of the similar type. Next question is, x square minus y square is equal to px minus qy, 4xy is equal to qx plus py, and x square plus y square is equal to 1. Eliminate the variables x and y, form the condition in terms of p and q. So in order to start solving this question, what we do is, first step, you multiply this with x and you multiply this with y, and what do you get? X cube minus y square x will be equal to px square minus qxy. Sorry. Now if I multiply with y in the next equation, you get 4xy square will be equal to qxy plus py square. If I just add them, minus qxy will get cancelled with respect to plus qxy. And if I just add them, what we are getting on the left hand side, we get x cube plus 3xy square is equal to p times x square plus y square. Just add them on both the sides. So when you add them, qxy gets cancelled, and the left hand side is x cube plus 3xy square. On the right hand side you have p into x square plus y square. We already have the value of x square plus y square, which is 1. So substitute the value of x square plus y square here. So you get the value of p. P is equal to x cube plus 3x y square. Now let's find the value of q also. Now substitute the value of p, maybe in the second equation or the first equation, whichever is comfortable. So maybe let's take the second equation. We have second equation as 4xy is qx plus py. Wherever we have p, we can substitute x cube plus 3xy square now. So 4xy is equal to q into x plus y into x cube plus 3x y square. Now I can take x common from both these terms. I have 4xy is equal to q into x. If I take x outside, I get x into y plus x square plus 3y square. I can cancel x also. This term also has x, this term also has x, and this term is also having x. So once you cancel x, we get 4y is equal to q plus y into x square plus 3y square. Now the q value is given by 4y minus of yx square minus 3y cube. Any doubt in this? So this is not looking in the standard format as this number is looking. So instead of writing like this, what we do is we want to convert this into standard form. So for that, what we are doing is we will write 4y as 4y into 1. 4y into 1 is also 4y only. So in place of 1, what we do is now we substitute the value of x square plus y square. So what do we get? 4y into x square plus y square minus yx square and minus 3y cube. So if I open up the brackets, I have 4y x square, 4y cube minus yx square minus 3y cube. If I add all of them, 4yx square minus yx square will be 3yx square and 4y cube minus 3y cube will be y cube. Now this is the value for q. So let's write q also here. So q is 3yx square and
3y.
y.
So you can take y common. No.
So we got p and q values now. If I just add p plus q, what do I get? P plus q is nothing but x cube plus 3xy square plus 3yx square plus y cube, which is the formula for x plus y whole cube. That means when I add p and q together, I am getting the formula for x plus y whole cube. If I add p plus q is nothing but x cube plus 3xy square plus 3yx square plus y cube. Similarly, if I subtract them, p minus q, I get x cube plus 3xy square minus 3yx square minus y cube, which is nothing but x minus y whole cube. So when I'm adding them, I am getting x plus y whole cube. When I am subtracting them, I am getting x minus y whole cube. Now let's simplify in terms of x and y this equation. If I take 3 onto one side, what do I get? P plus q whole power 1 by 3 is x plus y, and p minus q whole power 1 by 3 will be x minus y. We also have the condition x square plus y square is given as 1. I can also write x square plus y square as x plus y whole square plus x minus y whole square by 2, because this is a square plus b square plus 2ab, and this is a square plus b square minus 2ab plus 2ab and minus 2ab gets cancelled. You get 2 times of x square plus y square. If I cancel that 2 and 2, you get x square plus y square as the same thing, but x square plus y square is given as 1. Now in place of x plus y, now I can substitute p plus q whole power 1 by 3 here. In place of x minus y, I can substitute the value of p minus q. So what do I get? In place of x plus y, if I substitute this, I get p plus q whole power 1 by 3 whole square and p minus q whole power 1 by 3 whole square by 2 is equal to 1. For a power m, whole power n formula is a power m into n. You write this as 2 by 3 p minus q whole power 2 by 3 is equal to 2. So as the x square plus y square value is given, that's why we are writing the given variable x plus y and x minus y as x plus y whole square and x minus y whole square. If this value is not given, we might have used a different format here to simplify the given question. So whenever they give you questions based on elimination, always you need to first find out the variables, or they simplify the variables in terms of constants, and we have to substitute those those constants in any of the equations to get rid of the variables, because in the final equation you should not have x, y, z at all. Let's take one more question.
Sir, Borivali.
Okay, what's the
हो
answer?
गया.
What's the answer?
C cube is equal to 3b raised to 4 plus a raised to 4 by 4a cube.
4a cube. It should be 4a.
Yeah.
It's not 4a cube, it's 4a. Yeah, it's right answer.
Sorry. Silly mistake.
Okay, let's try the question. So we have to eliminate x, y, z. So starting from the first equation, we have been given x minus y as a, and from the next equation, x square minus y square is given as b square. I can write x square minus y square as x plus y into x minus y. In place of x minus y, I can substitute the value of a. So x plus y into a will be b square, or x plus y is given by b square by a. Now let's use this x plus y value and x minus y value to find x cube minus y cube condition. I can write x cube minus y cube as x minus y into
x square plus y square plus
x square plus y square plus
Plus
xy. Now this value is given as c cube and x minus y is given as a. I can write x square plus y square plus xy as x plus y whole square minus xy. Now we have x plus y value as well as x minus y value. X plus y whole square minus of x minus y whole square is given by 4xy. Now x plus y is b square by a. That means b square by a whole square, and x minus y value is a. A square will be 4 times xy, or xy value is given by b power 4 minus a power 4 by a square into 1 by 4. So this is the value of xy, and we already know the value of x plus y. Substitute all the values in this equation. We have c cube is equal to a times b square by a whole square minus of 1 by 4 into b power 4 minus a power 4 by a square. So if I just simplify this function, I have c cube is equal to a times b power 4. LCM is 4a square now. So LCM will be 4a square. So this will be 4b4 minus p power 4 plus a power 4 into a will be same as c cube. Now just simplify this. If I simplify this, a gets cancelled, and the numerator is 3b power 4. So what we have is 4ac cube will be equal to 3b power 4 plus a power 4. What is also same as, bring everything one side, 3b a power 4 plus 3b power 4 minus 4ac cube is equal to 0. This is your answer. So whenever they give you questions of this kind, go step by step and see wherever is the possibility of getting rid of elements. Just see, are you able to get rid of x plus y, x minus y, or maybe x and y at the same time. When it is not possible to get rid of x and y at the same time, we will be using the square or cube method by finding the variables step by step. Like first using x minus y, we found the value of x plus y. Using this two, using this, we found the value of xy. Once you have the value of xy, we have used the formula with respect to x cube minus y cube and substituted everything to get the final condition. Let's try one more question of the similar type. Everyone try this question. X plus y is a, x square plus y square is b square, x power 4 plus y power 4 is c power 4. Again eliminate x, y, z. Use the same method. What's the
b raised
answer?
to 4 is equal C raised to 4 is equal to 2a square b square minus a raised to 4.
No. Check your calculation again.
Sir, C raised to 4 is equal to b square 4b square b raised to 4b square plus a raised to 4 plus b raised to 4 minus 2a square b square by 4.
Tell me the answer.
Sir, Kalyan. Plus a raised to 4 minus b raised to 4 minus 2a square b square.
Repeat the answer.
Sir, c raised to 4 plus a raised to 4 minus b raised to 4 minus 2a square b square is 0.
Yeah, that's the answer. Anyways, let's solve this question. So starting from the first condition, if I square the first condition, what do I get? X plus y whole square is a square, or x square plus y square plus 2xy will be a square. Given the value of x square plus y square is b square plus 2xy is a square, or 2xy is written as a square minus b square. Now using x square plus y square is equal to b square condition, if I use x square plus y square is equal to b square, and if I square it on both sides, what do I get? X power 4 plus y power 4 plus 2x square y square is equal to b power 4, but x power 4 plus y power 4 is c power 4. Now we already got the value of 2xy, so in place of, or maybe let's find the value of xy. Xy is a square minus b square by 2, so in place of xy you substitute this value, a square minus b square by 2 whole square will be equal to b power 4. If I just simplify this,
Sir, answer ये है क्या? B raised to 4 minus A raised to 4.
hold on. So just take LCM. Just expand this. You get 2c power 4 plus a power 4 plus b power 4 minus 2a square b square is equal to b power 4. Sorry, 2b power 4. If I bring this 2b power 4 this side, you get 2c power 4 plus a power 4 minus b power 4 minus 2a square b square will be equal to 0. See, we have been given 4 equations, and this consists of 4 variables. Try to get rid of x, y, z and u. See, add missing term on both left hand side and right hand side, so that you can make all the right hand side terms as same in all the equations. So if I take the first equation, the term which is missing is ax. If I add ax on both sides, what do I get? X plus ax is equal to ax plus by plus cz plus du. Similarly, if I add by in the next term, I get y plus by is equal to ax plus by plus cz plus du.
Yes, sir.
If I add cz, z plus cz will be ax plus by plus cz plus du. And if I add du on the both sides, Add AX in the first equation on both sides, add BY in the next equation on both sides, add CZ in the next equation on the other both sides, similarly add DU on both sides in the last equation. And if I assume the same variable which is on the right hand side as AX plus BY plus CZ plus DU as some K, then what is the simplified form? The first equation is X into 1 plus A is K, Y into 1 plus B is also K, Z into 1 plus C is also K, and U into 1 plus D is also K. Now from here you can find the value of X. X is K by 1 plus A, and from here you can find the value of Y, K by 1 plus B. From here Z will be K by 1 plus C, and from the last equation K by 1 plus D. Now I have the values of X, Y, Z and U. I can substitute back in this equation. AX plus BY plus CZ plus DU is equal to K. Substitute the values of X, Y, Z and U in that equation. What do we get? So if I substitute there, A into K by 1 plus A plus B into K by 1 plus B plus C into K by 1 plus C plus D into K by 1 plus D is equal to K. Now you can cancel K in all the terms. So basically what we are getting the final term, A by 1 plus A plus B by 1 plus B and C by 1 plus C plus D by 1 plus D will be equal to 1. So whenever you see these kind of equations, always start with this approach, add the missing term on both sides and see whether if you can make the right hand side as same. If you are getting the right hand side as same, it will be easy to simplify with a particular assumption as a single variable of the right hand side and then solving it using the same thing. Clear, right everyone?
Yes, sir.
Practice more questions from your book, INMO book. You have these kind of questions in your INMO theory of equations. Solve questions from elimination of variables and solving of the equations. The next class will be also something based on the elimination of variables and solving of the equations, but it won't be a direct approach. We'll be using this elimination in order to solve a different question. So there will be an application of all these things in the coming chapter. So make sure you practice this question.
Yes, sir.
Thank you.